All right, so in this video, again, just kind of going to do more of a hodgepodge, starting with some financial stuff, and then we'll get into a little bit of sequences and series stuff. So question number 2 here, again, this is it's on Canvas, the actual document, so you can go through and start working through some of these on your own first, and then come back and watch the video. But we're going to jump right in here. So in this question, it gives us a table of there we go. A table of conversions, and so in this table, it tells us that these are all one. So one US dollar is 0.64 Great British pounds. 1 US dollar is let's use not 1 US dollar. So 1 franc. 1 franc is 0.12 Great British pounds. So what I did is over here on the side, I set up exactly what that information tells me. 1 US dollar is 0.64 Great British pounds. So what we want to know in part A is if we're calculating P is asking us what is 1 Great British pound, or what does 1 Great British pound equal in US dollars. So in this little equation I have here, what I want to know then is what is one of these equivalent to in US dollars. So if I divide by 0.64 on both sides, that will give me 1 over here. And then I need to take and divide 1. Is it going to work? There we go. 1 divided by 0.64. And we get 1.5625, but we want to round that to 2 decimal places as it says in the directions. So P is 1.56. And same idea here with solving for Q. I have a similar equation set up here. And again, I want to know what 1 US dollar is. So I'm going to divide by 0.19. And again, I have a similar calculation to do. 1 divided by 0.19 or 0.19, and I get 5.26. So there are the 2 conversions, part A rather. In part B, it says we have Joe has $1,500 to invest, and assuming that no commission is charged, I have the conversion set up here already as a dimensional analysis. So with dimensional analysis, you want to make sure your units cancel. So we're starting with the 1,500, and this is the conversion we're given. And so my units cancel. So really, I'm just taking 1,500 times 0.64. And that gets me 960. And that is Great British pounds. In part 2, now assuming the bank charges 1.5% commission, that means we've converted to Great British pounds, but now they are going to charge us commission. How much in British pounds does Joe pay? Well, here's what we have. We know how much he got, and the commission is 1.5%, which is 0.015. So I need to take 960 times 0.015, and that gets me 14.4 Great British pounds that I would pay in commission. So that is my answer to this question. It's the commission. For part 2 is how much do we actually receive? Well, that means I've got to take the 960 that I originally got minus the amount of commission, and that will be the total that Joe actually gets to actually spend, right? So if I subtract that, it'd be 945.6. Again, that is in pounds. Okay. So now Joe has his money and he decides to invest 700 of it in a savings account. So this is a TVM question, TVM solver. So remember apps, finance, TVM solver. And I have some of the things labeled already. You'll see we have the present value, we have the interest, we have the compounds per year, how much interest. So we need to solve. For something first. Will the 700 earn in 4 years? So it's 4 years compounded once per year. So 4 times 1 is just 4. You could have just typed in 4 there. 5% is the interest. Present value is negative 700. Future value is, I don't know yet. And then payments per year, compounds per year, that's just 1 because it's compounded annually. It doesn't say anything else about per year or months per year or quarters. So I need to solve for the future value. But that right there is not my answer because I still need to figure out how much interest it will earn. So not just the total worth, but the interest. So that means I have to subtract, I have to take present value minus, future value minus the present value. So that means I need to take this answer, 850.85, and subtract 700, which gives us 150.85. For the next part, how many years? So we need to solve for n, capital N. And then we'll stop and think if that actually is our answer. How many years do we need to invest 700 in order for that 700 to earn at least 200 in interest? So 200 in interest would mean the future value has to be 900. So let's come back over here and say, okay, so future value 900. It's still compounded yearly. The interest is still the same. The present value is still the same. It's the capital N. And so capital N in this case is number of compounding periods. And in this case, the compounding periods are yearly. So this does represent years. So 5.15 years. But we want to know when we have at least 200. So that happens kind of toward the beginning of that 5th year. So what that means is if we said 5 years, then we wouldn't quite have that 200 in interest. So that means we have to say 6. 6 years is when we would have at least 200, right? So keyword at least. For part D, after 4 years, Joe has a total of 900, same percentage, compounded annually. How much did he invest? Give your answer to the nearest British pound. So again, a lot of the information is still the same. This is still negative 700, still 900, 5%. This is 4. How much did he invest? The present value is what we're solving for. So alpha enter on the present value. And that means, so our present value, if we invest 740.432 and so on. So if we invest that much, that means we would have 900 in 4 years. So what we need to think about, though, is if it says to the nearest 1 Great British pound, so that would be here. So based on this, I would keep this a 0. But if I want to have 900, if I only invested 740, I would be very close, but not quite to 900 in 4 years. So that means I would need to say I need to invest 741 to make sure. So 741 to make sure that I have that 900. Okay. So a lot of this other stuff is, again, just good practice, good review, things to be familiar with from this unit. One thing I want to talk about, number 1, you can see on the screen from 13B. Just looking at commission, if you do calculate the commission, or if they ask you to calculate the commission, or what the commission is worth, then you need to multiply by the percentage, right, as a decimal. In the previous video, I showed you a way that you could figure out how much that you actually are converting or get from the conversion. But in this case, we want to know the commission, so you do need to multiply by that 0.018, and then you need to take that answer, which is 21.6, subtract it from the 1200, and then finish your conversion for part B. Okay, so you can try finishing that one up. Let's move on to a little bit of sequence series stuff. In number 12, you can see highlighted, I have an arithmetic sequence. Arithmetic sequence starts 23, 36, 49, 62. What is the first term of the sequence to exceed 100,000? Okay, so this is where we want our calculator to maybe do a little work here for us. But let's first start with what we know. If it's arithmetic, that means there's a common difference. And common difference being if I take 36 minus 23, that should be the same as if I take 49 minus 36, 62 minus 49, so on, which is 13. My initial term is 23. So let's fill in what we know. We know u sub n equals my initial term plus n minus 1 times our common difference. And what we want to know is the first term to exceed 100,000. So what I want to know is, first of all, we could think, okay, so is 100,000 a term in the sequence? So is there some term number, is there some position in the sequence that has a value of 100,000? Well, we could plug it in and find out. So we can take and plug in 100,000 for u sub n. And then solve. So kind of working backwards here, we take 100,000, subtract 23, divide by 13, and then add 1 to it to work backwards to solve there. So in this case, the term, so u sub 7,691.538, so on, so on. Well, there is no term number of that. So the first term to exceed 100,000 would have to be the next term, rounding up, basically. So u sub 7,692 is greater than 100,000. So n equals 7,692. That is the first term of the sequence to exceed the value of 100,000. Okay. Let's take a look at number 5 here, and I think we'll call it for this video. So number 5, the geometric sequence. Geometric sequence is 12, negative 6, 3. So find the first term, u sub 1 and common ratio for the sequence. First term is easy. It's literally the first term unless otherwise stated. So u sub 1 equals 12. Common ratio is taking any term and dividing it by the one before it. So negative 6 divided by 12 is negative 1/2. Okay. Find the general term. That's easy. I have u sub 1 and I have my common ratio now. So I can easily plug those two things in. So u sub 1 is 12. So u sub n equals 12. My common ratio is negative 1/2 n to the power of 1. And then it says, hence, find the 13th term. So u sub 13, and this is just plugging in, and it says sequence as a fraction. So when I plug this in, I have 12, and then negative 1/2 times 13 minus 1. Sorry, not times, to the power of 13 minus 1. So let's just go and plug that into our calculator. And I'm going to take 12 and then make sure, in this case, use parentheses, negative 0.5, right? So negative 1/2 to the power of 12. And I get a decimal. But remember your calculator, so I can do second, and the negative button gets you the previous answer, right? So the previous line, and then go to math, and then the first option, fraction. So math fracket, and we end up with 3 over 1024 as a fraction. Okay. All right, and let's take a quick look actually at a couple of these questions. These are series questions. So find the sum, right? So series, sum of the first 10 terms, and so on. So first thing you need to identify is what's the pattern. So for part A, notice there's a common difference of 2, so it's arithmetic. For B, the common difference is 4. So just making sure these, right? So these are going to be arithmetic. These down here are going to be geometric. Okay, so just be careful there. But when it's asking us to find the sum, so let's take a look at part A real quick. So sum of the first 10 terms, this is where we have to make sure we know what information we have to use which formula. So in this case, I know the initial term and I know the common difference. So the formula of taking, so the number of terms, so 10 divided by 2, and then take 2 times the initial term plus n minus 1 times the common difference. That is the summation formula for an arithmetic sequence. For a geometric sequence, my ink doesn't like when I scroll so fast. So for a geometric, don't know where that went, there it is. For a geometric sequence, let's see, my common ratio is 3. So this is for part A. So the sum of the first 8 terms, and again, this is where it doesn't matter which formula you use, but since R for this one is 3, multiplying by 3, take the initial term, so 2, and then times your common ratio. I'm going to use the one where it's R to the power of n minus 1. And then again, that's the way that you can avoid negatives. Either way, the series formula for the geometric series, it doesn't matter which one you use. Just make sure you plug it in correctly and then plug it into your calculator correctly. Okay. So for those, again, these are all questions that you can bring to the live conferences if you have them, or if you want to see a little bit more of this in depth, or just other questions, whether it's related to apps or other things. So feel free to bring questions, and we'll see what we can do. See what we can do to help. Okay. As for now, stay safe, stay healthy, and do your best to make progress. That's all I want. That's all I ask. Just make sure you're making progress, moving forward, and asking for help. Ask for help. Email, contact me when you need it, please. Okay. Take care.